we're set to go here. So welcome back to another edition of our monthly lunch break sessions. These lunch breaks are hosted by the Christmas Tree Council of Nova Scotia's research team, which is led by myself out of Perennia Food and Agriculture Incorporated. So jointly, we host these monthly sessions. We always have them over the noon hour, so noon to 1 p.m., usually on the last Tuesday of every month. So that gets us about 12 throughout the year. Sometimes we skip through December, so it just depends. And if you're not already on the mailing list to get this pre-registration link, which I think all of you are able to find for today, you can email Brittany at any time to get put on that mailing list. And her email is displayed there on your screen. It's outreach@ctcns.com. So as you're well aware, our sessions are hosted through online video conferencing via the Zoom application, and that is just a restriction that we're dealing with in COVID. So hopefully some of these meetings will be able to have them in person going forward, but for now, this is where we're at. And if you aren't able to join us over the lunch break session, you can access any of these videos at any time on our YouTube channel, Christmas Tree Council of NS. And if you just go ahead and Google that, it'll bring you right through to the homepage. So today's session, this is our May 2021 session. Today we're going to talk about Nova Scotia Christmas tree soil fertility goals. And this is going to be based on the industry-driven research and innovation project funding that we had for the last 2 years and the results that came out of that work. So our outline for today, we're going to cover off some of the basics of Christmas tree soil. So what you should be looking for if you're investigating in a new site. We're going to hit on that pretty briefly and then head into how to use the Nova Scotia Soil Survey maps. So I think some of you would be familiar with those maps by now, but if not, I'll show you how to access them and also what they look like when you actually open it up for your individual county. Then we're going to get into how to take a soil sample. So the theory behind why it's important to look at doing that, and also how to actually take the sample and submit it to the lab. And the biggest chunk of this presentation today is going to be reading the soil test reports, and I'm going to base a lot of that on the results that came out of our research for last year. So then finally, we'll finish off with getting into making management decisions and kind of how you look at your soil tests to help you pick out certain fertilizers or amendments that might complement your soil. Okay, so the Christmas tree wish list. I'm sure if anybody sat through a presentation with me, you've seen this before. This is the very basis of what you need for Christmas tree soils. So we always say there's 4 main things. Drainage, which is pretty self-explanatory. You need a well-drained site. Balsam fir does not like wet feet. Fertility, so that's where you start to look at your nutrients and the actual health of your soil. Moisture, you have to be able to hold on to soil moisture, and usually that comes with soil organic matter. That gives you the ability to hold on to soil moisture within the organic matter layer at the surface of the soil, and what that does is really helps out your seedlings. And finally, depth. Of course, Christmas trees grow to be pretty tall, so we know very well that they have a lot of root mass. So that root mass has to have somewhere to go, and that's where the depth of your soil comes in, and also the ability for the roots to actually penetrate through that soil. The Nova Scotia Soil Survey maps. So I think many of you would have seen these. If you did the nutrient plans with our research team this year, you would have got a copy of the map with your individual lot on it. But these maps were conducted several years ago. There's a map for everywhere in Nova Scotia. You can go in and sort them through by county. I've got the list there at the bottom, but you can also just search Nova Scotia Soil Survey maps and that will bring it up as well. I believe some libraries would still have the original hard copies, and you can request a hard copy from them as well. So the link is published there on the bottom. If you need it, you can email me directly, or you'll be able to get it on the recording of this video. But what it will do is it will bring up a map for your area. So you can see there's a picture here that's zoomed in on Maplewood. So that's one specific example that we're showing. And you can see the different color patterns. Those changing color patterns actually represent differences in the soil type. So when you have your map and your full legend up, you're able to get some characteristics of what soil type you're actually dealing with. And it's pretty interesting to do for a Christmas tree lot, because the vast size of a lot, in some cases, you can have several different soil types happening and also different types of topography and drainage. So sometimes you can look directly at the map and kind of solve the issues that you're seeing in your lots pretty quickly. So getting on into the soil sampling. So why do we soil sample? Well, it's hard to know what's going on underneath our feet. So we can look at a tree and identify that there's potentially something wrong with it. Maybe it's turning yellow, so it's got a nutrient deficiency of some sort, but there's really no way for us to correctly determine what nutrient deficiency that might be without taking a soil sample. So when we can't explain a problem in another way, and of course, pretty well all the problems that we face with Christmas trees, the tree just turns color. So it turns a reddish brown or turns a yellow. And for lack of, unless you can find a pest on that tree to help you identify the problem, you pretty well need to look at alternative routes, which is why we take soil samples. So what it helps us do is efficiently use resources. So all the inputs that we put in to try to grow a tree faster and better are really expensive. So we want to be cautious of our finances and make sure that we're not oversupplying our inputs or undersupplying to the point where it's not really being productive. Also, we have an environmental responsibility. So you always want to make sure that as an environmental steward, you're not providing more nutrients than is actually needed or can be used by the crop. We've talked about that in other presentations before. If we're putting on too much fertilizer, for example, we have the risk that we're going to have phosphorus and nitrogen runoff, which can cause a whole host of other problems, but that's a talk for another day. So for now, another reason we soil sample is environmental responsibility. Then avoiding other problems. So sometimes if you get your soil nutrients out of whack, you start to introduce new issues that might not have been there before. So one is canker. If you get your nutrients off, you can start to see a lot more canker in your tree lot than you might have alternatively. Another portion of that is record keeping. So in order to really know what's happening in our soils and to try to trace that over time, taking regular soil samples and keeping track of your reports and reading them and understanding them over the years can help you to diagnose new problems when you see them again. It's about experience. So when you get used to recognizing a particular nutrient deficiency, it's going to be so much easier for you to find that later on or look back in your notes and say, this is what happened in 2011, so it looks familiar again. And then finally, the thing that's different about Christmas trees is we have such a large window. So looking at a decade to produce a crop, there's always a desire to try to close that window. So we can certainly grow a tree without any inputs or without managing soils to some degree, but it's going to take a lot longer than if we really know what's going on and try to maximize the potential by providing optimal soil conditions. So that's the why. Now we're going to get into the procedure. So a lot of you would have had one of our research team members on your lots last year conducting your soil samples. And if you were able to travel around with them, you would have noticed that we tend to select trees in a randomized pattern. So for the particular project we were working on last year, we had to select trees of a certain age. But if you were to go out and just sample a full lot, what you'd want to do is walk in a zigzag or W pattern, we sometimes say. So depending on how best you can divide your lot. So the first step of that, I've got this broken into 3 little steps here, is to divide your lot into subsites. So if you look at that soil map, for example, and you see you've got 2 different soil types that kind of border each other on your lot, or if you have a really high site and a really low site, or a site where a lot of trees aren't doing so well, then there's probably a reason for that. So you're going to want to divide that up into subsites and take separate soil samples to try to get an indication of what's happening. So that's your first step there. Assuming you're going to manage these sites separately, you want your different samples. So you're going to create a little map for yourself and base your soil sample methodology off of that. So then your second spot, and this is within each of your subsites that you just determined, is to actually walk that pattern and take the soil samples. So our research team has a soil probe and we also have a soil auger. We usually end up using the auger in Christmas tree lots, more common just because we run into so many rocks. Both are pretty good tools though. What you want to make sure you're doing is taking composite samples. So you want to take multiple cores or multiple auger cores across the site and combine all that to get a good sample. So I usually recommend you take at least 20 subsamples per lot. If you have a huge lot, then you'll be taking many more than that. So in that W pattern or your zigzag pattern that you're walking across the field, and I maybe should have brought up a whiteboard so I could draw this out, but I guess we'll just have to visualize for now. Walking across your zigzag pattern, I like to count my steps. I find that works pretty well. And when you get more used to sampling lots, you'll have a good idea of how many steps you need to go in between your cores. So for example, let's say we're walking 25 steps. Every 25 steps across our W, we're stopping and taking a soil core. That core goes directly into a bucket, and you keep going until you've crossed your whole lot. When you get to the end, you're going to have a bucket probably full of soil, and you're going to want to make sure you mix that really, really well. So take out any sticks, take out any rocks, any grass, any matter that you're getting off that top layer there. We don't really want that in our sample. We want to make sure we have a nice, clean, consistent sample. And then really take the time to mix it well, because if you think about it, we're only submitting that little wee soil box to the lab, which holds maybe like a large handful of soil. And that's meant to represent our entire lot. So we've already limited ourselves by taking subsamples off of it. We're not taking a sample of everywhere in the lot. And we're going to limit ourselves more when we take that big bucket and put it down into just a cup or a cup and a half soil sample. So make sure you have them really well mixed. Then when you get to the point where you have a nice mixed composite sample, you're going to put that right into the soil box, and you can get soil box at any of your regional Department of Agriculture offices. They can hand them out to you or our research team. We always have some in the trunk of our car if you ever see us and want one as well. But what you're going to do is put that subsample right in the soil box and deliver it to the Department of Agriculture, who can get it through to their analytical lab. So when you submit that, make sure you're labeling it really well. So if you have multiple samples across different lots, label them with something that you're going to remember where you took that sample. So I run into a lot of growers will have purchased lots from other people over the past. So for example, the Smith lot, maybe if they purchased it from somebody named Smith. But if you take 4 samples off the Smith lot and label them Smith 1, Smith 2, Smith 3, you might not remember where you took those samples. So make sure you have a map, or you're labeling them like Smith lower site or Smith small lot, or you pick that type of thing. Just to make sure you'll remember, and also that when we get the soil tests back and look at them, we're going to know what you were talking about when you submitted them. So at that point, you're pretty well ready to submit your soil. You've got your label. The other thing you need to do when you submit a soil sample to the lab is to fill out a soil test submission form. So it's pretty easy to find on their website. I've linked it down here as well. It's just called Analytical Lab Soil Submission Form. And what they'll ask you to do in that form is fill out your contact information. They'll call you for payment. And one option that they give you is to copy your results. So if you do want help interpreting your results and you don't necessarily feel comfortable doing that on your own, you're welcome to put my email in at any time. And then when I get the results, I'll call you and we can walk through them together. They also have a pretty good document under their lab services heading, and that's linked there at the bottom as well. And it will kind of tell you how to take a soil sample. They also have one on understanding the soil test report. So they're both great documents. The only thing to keep in mind is that understanding the soil test report, that PDF is not necessarily based on Christmas tree soil. So a lot of times you're going to need some additional information, which is easier to find if you just go directly to our research team. Okay, we're going to get into the heavier stuff now. So this is what it looks like when you get a report back. This was just an example sample that we had taken. So this one was from Cobequid region. It was on a bit of a plantation style lot. So some of the values will look quite a bit different than what many of you would be used to seeing, but I'm just going to use it to show you how we look at these reports. So you can see on your screen there, there's 5 columns that go across there. So the first column is going to be your actual characteristics. So that's going to label off what you actually found in your report. Then the next 4 are going to be your sample results. So you could have up to 4 samples on a test report that you get back. So in this one, we have 2, block 1 and block 2. Let's just look at block 1 for now. So you can see if we start to go down the parameters on the left-hand side, we've got pH and pH units. You also have a buffer pH. Now, we don't pay so much attention to that. That buffer pH is just a measure of your soil's ability to resist change. So they use that in the lab to give you recommendations on liming and that type of thing, but it's not really an intrinsic characteristic of your soils. Then you get down to organic matter. So in Christmas trees, your organic matter is usually going to be good all the time because you have such good ground cover. So organic matter is that kind of black earthy layer right at the top of your soil horizon. And you want it to be relatively high. So you see that first one is 10.5. That's really high. That's exceptional. I generally say anything over 4% organic matter is good, but in Christmas tree lots, I really like to see 8. So this one is exceptional. The second one there in block 2, not as exciting. Then you get down, you can see I've got highlighted in blue here. These are kind of the fertility parameters that I tend to look at. So your first one, P2O5, that's a phosphorus measure. So if you think back to science, you'll remember that P is the elemental sign for phosphorus. Then K2O, below that, you'll remember K is potassium. So that's your potassium measure there. There are conversions to get it directly into phosphorus and to potassium, but for now, we're just going to go with these values because this is what I usually give in recommendations anyway. You've also got a measure there of calcium and magnesium. These ones can be intertwined. So you usually look at either trying to achieve a calcium to magnesium ratio or trying to achieve adequate magnesium across the lot. And then the rest of that stuff down there, we don't tend to look at as much unless we're trying to diagnose a specific problem or we have a grower that's interested in looking at micronutrients. So for the purposes of our presentation today, that's all we're going to look at. So this is just the same test. It's zoomed in that yellow thing, in the yellow highlighted with what I was discussing. So we're going to look at today pH, which is just in pH units. And you'll remember from high school science that pH is measured on a scale of 0 to 14. So 14 being highly alkaline, lower numbers being highly acidic. So I think lemon juice falls around 3, and then your neutral value is usually around 6 to 7. Water being around 7. So that gives you a bit of a guidance as to where you're expecting to be. We're going to look at organic matter percentages. So I said earlier that 10.5 is exceptional. We want to be somewhere in the range of 4 to 8. Then we're also going to talk about phosphorus, potassium, and briefly on calcium and magnesium. So I just also want to note that these values, when you get them back from our analytical lab in Nova Scotia, they're in kilograms per hectare. Now, if you start to look at some data that comes out of the States, sometimes you'll get parts per million, sometimes you'll get some different measurements. So there's 2 risks with that, looking at data from elsewhere. They may not have used the same lab technique to actually get the information, which means that if you're taking your soil test and try to interpret it with an extension form you found from the States, for example, it's not even going to be near close the same numbers or relevant. The other part of that, if you're looking at pounds per acre, for example, there's a conversion factor that goes along with all of these. So trying to compare your kilogram per hectare with a pounds per acre of the States, also not going to work. So you've got pretty well 2 risk factors there with trying to use other extension materials, and our research team is happy to help you out with those conversions if you do need them. But I just want to make sure that kind of everybody who's interested in looking at their soil test reports are aware that there are some risks associated with going elsewhere. So moving on, here's what all that stuff means. And I shared this little infographic pretty often, so I think everybody's starting to get a good handle on it. We talk about pH a lot. So I think we all know that Nova Scotia soils are typically very acidic, and that's just because of the parental material. So across all of Nova Scotia, our soils are acidic, but particularly in forestry and Christmas tree lots because they haven't been limed and maintained over the years. So it's a bit different than looking at a cornfield, for example. So most of the pH levels that we get back are sitting around 4. Some of the higher ones, we start to get up to 5. Very, very few ever fall over 5 in Christmas trees. So that's generally what you're looking at. However, the recommended level for balsam fir, if you want an optimal condition for balsam fir pH, you're usually looking at 5 to 6. So I tend to say 5 to 5.5 is what we're looking to strive for. There are some other risks associated with raising your soil pH. It can, one of the advantages that we have in Christmas tree lots is with acidic soils, we don't have as much weed competition. So that's one plus, I guess, but to be truly optimal, we should be aiming for 5 to 5.5 in your pH levels. The next thing there is your soil organic matter. So we talked about that. We're looking to be somewhere 4% to 8%. Soil organic matter does a whole host of great things for your soil. It's that nice top dark earthy layer. It can hold water, it holds nutrients, it helps with transport, and it's food for the microorganisms that are present in your soil as well, which is always good to put back into that cycle. Phosphorus, so that's that P2O5 that we talked about on the soil test. It supports root development. So we talk about how over the years we're not able to have as good a germination, or seedlings don't do as well, or the roots don't necessarily grow to hold them when we get a bunch of frost heaving. Part of the reason for that could be that the phosphorus is low across Nova Scotia and Christmas tree lots. So if we're able to bring our phosphorus up just a little bit, we should have much better root development, more root mass, and be able to hold during those frost heave events. Potassium, that one is a little bit cyclic, so it goes into the other nutrients as well. Potassium supports growth, so it's required for growth in anything green, really. So all plants need potassium for growth, and it also helps Christmas trees out with disease resistance, so that's an important one too. Calcium is what's helping you deal with stress, has a little bit of help with disease, and it does support absorption of nutrients, and calcium is linked back to your pH levels, as is magnesium. So I guess that's another balanced chat for another day, but your magnesium component, that's in chlorophyll. So that one is pretty important for Christmas trees to get that nice deep green color. And it also supports the balance with calcium, which goes back to our pH levels again. So if any of you had your fertilizer recommendations done this year, you would have noticed that sometimes we recommend a liming amendment, and there's 2 different limes that we recommend, the difference being that one has a magnesium component to it. So in sites with lower magnesium, you can see we often recommend dolomitic lime. That's because it has a magnesium component to really help boost that chlorophyll in the trees and get that desirable green color. All right, so on that, professional nutrient management planning, this is a pretty standard concept across much of agriculture. And what it's based on is that a professional is developing recommendations to try to get to an optimal soil condition for a specific crop. So in our case, it would be for Christmas trees. So what we use to do that is your soil test reports, your tissue test reports, so the actual foliage sampling that we conducted last year as well. Management history, so we keep track and keep records of what's actually been going on the land as far as inputs, and that helps give us a better idea of what's already existing. Resource access, so a good nutrient planner will keep in mind what you actually have access to so that you're able to implement the recommendations. And finally, it's mainly based on the concept of 4R planning. So 4Rs being the right source of the input that you desire, and usually that's based on fertilizer, applied at the right time, so the right time of year when the plant can use it best and you cause the lowest environmental risk, applied in the right place so that the plant is able to access it so the tree can get to it quickly, and finally applied at the right rate, so making sure that the rate that is recommended is actually what that plant needs and has the ability to take up in a reasonable amount of time. So that's what is based on NMP, or nutrient management planning. So what we look at when we do nutrient planning for Christmas tree growers is technical information on fertilizer application and input recommendations. So we've always had this data available, but we talked earlier, not all of it's really applicable to us here in the Maritimes or in Nova Scotia. So most of that information was created for the States. So that's different soils than we have here. It's also a different management style. So a lot of the lots in the States are that plantation style model. So it's, first of all, it's a lot easier for them to manage their soils locally around the trees, but they also require different soils than we do to do management style that way. So we've got an advantage in that balsam fir really likes our soils because they are a bit acidic. So we're in a pretty unique position, but with that comes a lot more limited resources on what is actually needed for our soils. So we talked about earlier, what we're looking at doing with this nutrient management planning is trying to shorten the life cycle while maximizing tree quality. So we're just trying to narrow that window a little bit without going too crazy on our inputs. So we started out doing this back in 2019 was the first year that we conducted the soil and foliar survey. There weren't many sites sampled in 2019, so I tend to base most of my data on the results we got last year from fall 2020. So we had a province-wide soil and tissue sampling project, which was conducted under the calibration and correlation of soil nutrient status with needle nutrition concentration in Christmas tree, specifically balsam fir, lots. And the objective behind that was to develop enhanced fertilizer guidelines. So this was a research project that was funded under the Canadian Agricultural Partnership Industry-Driven Research and Innovation Project. And last year, under that project, we were able to submit over 1,000 samples. So that gave us quite a range of data very quickly that we didn't previously have anything to base on. So I'm going to talk now about some of the results that came out of that. The design of that project, so we didn't just collect soil samples. We were actually identifying approximately 10 trees on each grower's lot. So this is a sample on a per tree basis, if that makes sense. So for each tree that was identified on everybody's lot, we took a soil sample directly around the drip line of that tree. We took a tissue sample, so took some of the needles and actually figured out the needle nutrition within that sample. We also collected some quality characteristics. So these are similar to the evaluations that we use on the smart trees. So we took tree height, needle length, brush color, which could be a range from kind of a yellowy pale green through to a dark green, and also we were recording silver and blue tinges. The brush angle, so that's downward, upward, 45 degrees, that was recorded. Brush ranking, which is basically a measure of bottle brush. So we had 4 options there. We could have single row, double row, partial bottle, or full bottle. We ranked each tree on its overall potential. So these were mainly about 4-foot trees. So looking at how well they were doing and comparing them to all the trees that our team had seen in our lifetime and giving them a ranking out of 10 to see how well we thought they were doing. We also collected a lot of data from the individual growers. So we collected data for the past 5 years on fertilizer use, pesticide use, any other soil amendment records, foliar fertilizer, if anybody had applied that, planting history, so how many trees were actually being planted on an annual basis, ground cover history, what weeds they were seeing, equipment usage, what they had access to, and we also asked individual growers to self-identify their successes and failures over the past 5 years. So it ended up being quite a bit of data, but really helped us out when we tried to do recommendations this spring. So I'm going to get into the results now, and all these results were shared in the Christmas Tree CTCNS journal last spring. So that was my spring article, and there are full-size tables in that included if you do get soil test reports that you want to compare to. But I'm going to read this because I think it's pretty important to keep this in mind when you're comparing your sites with the averages that were presented in those tables. So generally speaking, if your soil test results were falling within the averages for your region, that's a good sign, so you're on track. However, when you're comparing those results and interpreting the tables, keep in mind those results depict every tree that we sampled. So that's inclusive of the best trees, but it's also inclusive of the worst trees that we sampled. So of the 548 trees that were sampled under that project, nobody got a 10 out of 10 ranking. So none of the trees were perfect as determined by our team rankers. However, some of them got a 1 out of 10 ranking. So some of them were pretty bad. Of the 548 trees sampled, you can see that about 3.5% were the top trees, we call them, or trees that received a ranking of 8+. So that's 8 or 9 since there were no 10s. So 19 out of 548 trees. So we had some pretty fussy graders, I guess you could say, but that's good. That brings our quality up. And our worst trees, is, for lack of a better term, that's what we've been calling them. We had 13 of those. So 2% of the population that received a ranking of 3 or less. So 1, 2, or 3. And most of the trees, therefore, received rankings between 4 and 7. So mostly pretty average. So when you look at this table, which is just a condensed version of what was actually put out in the Christmas Tree Journal, you're looking at all the trees sampled. So you have included in this those 19 top trees, and you also have, I think it was, yeah, and you also have those 13 really poor trees. So you have some that bring the population up, some bring it back down. So that's just important to be conscious of. So this is broken down by individual region, and Nova Scotia is in green there at the bottom. So I'll talk briefly about Nova Scotia. What you can see from that one, the average for pH in Nova Scotia was 4.45, which is still quite a bit lower than that 5 number we were looking at for balsam fir, but certainly not unexpected. And if you look at kind of the bottom row in that table, you can see that the range there was 3.45 to 5.83. So we still had tree lots that were falling well below that range. And 3.45, in my opinion, that's really acidic. You're approaching lemon juice there. So that's something to be conscious of if your samples are falling that low. Organic matter, our average is 7.42, which is great. That's right on that 8% goal. But you can see the range there is really big as well. So we've got 1.9 going all the way to 47, which would have been a fluke. That's an outlier that we did end up taking out. But I'm thinking anything that's got an organic matter level below 2% in a Christmas tree lot, that raises some concern. That's pretty well bare soil. And, oh, sorry. Then you can see we get into our phosphorus and our potassium. So those are kind of the main nutrients that we look at on the soil test. So P2O5, just as a reminder, P is for phosphorus, K2O, just a reminder, K is for potassium, and those are listed below in the headings there. And you can see the Nova Scotia, the ranges for both of those in that very bottom row are just huge. So there's such a variety happening across the province for fertility and Christmas tree lots that it's really interesting to be able to determine what we're actually striving for. So the average for Nova Scotia phosphorus, 80, and for potassium, 138. That sounds pretty bang on to me. The other things that you can look at breaking down is Cobequid, Southwest, and Northeastern. So Northeastern would be your Antigonish-Geiswa region. Southwest is going to be Lunenburg County, New Ross, that area. So you can see the differences there. What's kind of neat, I mean, your organic matter levels are pretty similar across, a bit lower in Cobequid region. Your phosphorus levels are much bigger in Cobequid, actually triple what the average was for the Antigonish area. So that's pretty interesting. And then your potassium is pretty well close across all 3 regions and close to the average. So those are just some things to keep in mind. The other thing I'm going to talk briefly about is magnesium. So when I look at these reports, I usually aim for magnesium of 100 kilograms per hectare. And if you're not at that level, then it's time to think about adding some magnesium components in to try to approach that. So in Southwest region or Lunenburg County, New Ross, their average was well below 100. Northeastern's also below, but what's interesting is Cobequid is at or over that number. And we're also conscious that this includes all of the trees sampled, not just the good ones. So now let's talk about the good ones. Let's try to figure out what was actually different in the soil reports that came back from our top trees, so those that were ranked over 8, as opposed to kind of our worst trees or our kind of bottom 2%. So we talked earlier about the evaluations. These are what we were actually looking at for the trees when we were trying to determine which ones were the best. So the height of the tree, and for this project, we were selecting things around 3 to 5 years in age. The needle length, so that the methodology for that is that we just look at 5 individual needles. We try to go for the longest ones and do an average to figure out the needle length. Whorl bud set, that's the greatest number of buds per whorl on the tree. Internodal budding, greatest number of buds on an internodal branch on the tree. Color, so I mentioned earlier, we've got a scale for that, kind of blue silver to tinge silver to dark green. Branch angle, so you can have downward, upward, good, or 45 degrees. And your brush, single row, double row, partial, and full bottle. So our overall ranking, if we take those trees, which we ranked out of 10, and look at what their characteristics were, this is what you get back. So you can see the averages are displayed in yellow at the bottom there. This is your top 3.5% of all the trees that we sampled. You can see there's quite a bit of silver here in the color. Some of the internodal buds are pretty high, average 3.4, but you can see there's a few in there that are like 14, 25, 16, which is phenomenal. Your branch angle is average across everything. Your bottling of brush is at least partial everywhere. And our average rank there is 8.1. So you can see you just have a couple 9s out of all the trees that we were looking at. So now if we keep that in mind and go to our bottom 2% of trees, or our worst trees, and just bear with me, we are going to get back into the soil results, but I want to make sure this is laid out pretty clearly. The big difference here is that we're not getting as much silver in the coloring of the brush, so that desirable tinge. We've got one here that was yellow, a lot of light greens, just plain old green, not even that dark in some cases. Your branch angle is still kind of okay. You've got some average branch angles, but you have some that are poor, some that are flat, so that's just straight across. Your rank is low across all, so these are trees that ranked 1 to 3. Your budding is a little bit lower. You can see you've got some 2s, you've got 1 in there with none. Whorl bud set, quite a few less as well, and your needle length is not as large. So pretty well all the characteristics that we look at, when you sort them out by your worst trees, compare them to your top trees, there's a big difference. So here's your soil results for our top trees. So we talked previously about the results for all the trees. Now we've taken out anything that wasn't ranked 8 or higher. So this is your top 3% of trees across the whole project. And that pink bar at the very bottom there, that's your averages, but sometimes it's nice to look at the numbers as well. So I've got a first place ribbon here. These are our best trees. And when you're looking at your pH, some of these have pHs well over 4, so 4.93. We've got a couple 5s in here, average 4.63. And if you remember, that's about 0.2 higher than what our average was across all lots. Your organic matter levels are exceptional here. So I don't think there's any that are below 4, averaging 8.35, which we said earlier was a really good number to be at for organic matter percentage. When you start looking at your P2O5 into your phosphorus levels, we're averaging 111. And there's quite a big range through here, which was interesting as well. And your potassium range, you're over 150 for that too, which is higher again than our full samples. If you look at your magnesium, you're sitting at that 92 level. So we talked earlier, we said we're aiming for 100. So this is much closer than the full Nova Scotia all tree samples. Let's keep this in mind and go and compare it to our kind of bottom tier trees. So now our ribbon went from first place to a participation ribbon. So these are our trees that are in our bottom 2% of all the trees we sampled. That pink row, I brought that over from our top trees so we could compare it. But you can see from our top trees, we've got pH about 4.6. When we look at our lower trees, most of these are falling well below 4. We've got a couple 4.2s, 4.6. Organic matter level from our top trees, that was the number that was over 8. If you look at the percentages in the worst trees, some of these are still pretty good. So we've got a couple 10s in there. So that might lead us to believe that maybe organic matter isn't playing as much of a role as we thought. Phosphorus, we were looking at 111 from our other trees, and you can see in our worst trees, we've got some as low as 6 here, 6, 8, 12, quite a bit lower overall. Potassium, we were aiming to be over 150, so quite a few of those did accomplish that. However, we also have some that are kind of in the 50 ranges. And then your magnesium level, which was pretty interesting. These are quite a bit lower. So we were aiming to be around 100. We've got some in here in our 30s, 40s, 50s. So you can just start to kind of see what's contributing to the evaluation criteria that we're looking at. So I'm bringing this slide back up for our goals again. So we were looking at our pH. We were saying we want that around 5. Most of them are around 4.5, so that's pretty close, pretty okay. Soil organic matter, we need it to be over 4. Some of those were coming back 10%, which is great. Phosphorus, so we need that to support our root development. We were looking at that 111 number. Potassium, support growth and disease resistance. We wanted that over 150. Calcium and magnesium, we were looking at our magnesium to be over 100 or approaching 100. So that's where some of those goals were coming from. Now, this is a simplified chart so that we can kind of try to summarize all that discussion we just had there. So this is the soil averages from our project that I discussed earlier. So in green, you get all the trees that were sampled. So everything ranked 1 all the way to 9, which was our highest ranked tree. And then in pink on the bottom, you've got our top tree samples. This is our top kind of 2% that we just discussed in more detail. And you can see some subtle differences here. So if you look at your pH overall in your top trees sampled to your better trees, just a difference of about 0.2. So not really that substantial. Organic matter, we are getting a little higher. So we're over that 8% in organic matter when we get into our better trees. Our phosphorus levels quite a bit higher. So we're about 30 points higher here, kilograms per hectare. So in your overall trees averages for all the province of Nova Scotia, you're around 80. In your top 2% of trees, you're over 110. Similar for your potassium, our average across Nova Scotia is about 138. But if you look at our top trees, it's slightly higher, approaching 160. Your calcium levels almost double there, and your magnesium, as opposed to that 77 number that you're getting across all sites, you're starting to approach the 100 that we've kind of mapped out as well. So just some subtle differences across some things, but enough that we can definitely see a difference and maybe set some goals as to where our optimal conditions ought to be. And this will get better each year that we take more samples and add to it. So the last thing I wanted to kind of touch on, that whole discussion that I just worked you through is kind of the thought process that we take when we put together a nutrient plan for a Christmas tree grower. So this is the cover page of what our plan actually looked like when we sent it out. This is just our standard template, so it's nobody's in particular. But the contents that you have in that, you have a pretty broad property description, which does include individual aerial maps of every lot that was sampled. You also get the GPS coordinates for every tree that we took the sample on. You get your soil conditions, which includes the soil maps that we talked about earlier on, a more detailed explanation of how to interpret your soil test reports. You get our recommendations. So we do a recommendation for lime, particularly if you need some magnesium added in. And you get your recommendation for fertilizer. And we base that on kind of a conglomeration of the optimal conditions that came out of those top trees in this project, combined with a lot of calibrations and conversions of data coming out of the States for Christmas tree extension. And then we also put in your soil test and tissue test reports as appendices, and it ends up being about a comprehensive 20-page document that's detailed enough to give you a plan for the next 3 years as to what your trees really need. So we were pretty happy to be able to put those out this year. I think we completed close to 30, which had us pretty busy for a few months, but it was nice to see the interest in the uptake. So we're hoping we'll be able to offer this as a service again through the research team, and hopeful that it will be useful for years to come for growers. So if you have more questions on this, I know this was a longer session, but it's hard to fit that much information into any less time. I think I chat pretty quickly as it is. So if you do have more questions, you're welcome to contact myself or the other members of the team at any time. So I've got our contact information on here for myself being Jay. We also have Leanna on there, who's kind of our designated weed expert in-house, and Jillian, who's kind of our technical resource expert in-house. So you're welcome to reach out to any of us anytime, and I'm sure you'll get to know our new summer students this year as well. So.
I was just wondering, great presentation, by the way, very informative, but I was just wondering, how long does it take to put together the nutrient plan? And is there a cost to the growers if they want to get involved with that?
Yeah, that's a good point, Ryan. So this year, because we had that previous funding from 2020, we were able to take the individual soil tests for free. So the cost associated with that would have been our time to travel out to the lot, spend the day in the field collecting samples, and also to submit a soil sample is about $22 for each one that you submit. So that cost was covered last year through the funding that we had previously. To do a nutrient management plan, so this year, to try to speed it up, we had 3 of us working on it. So Leanna took on doing all of the mapping, I did the recommendations, and we had Jillian rolling in with kind of the fill in the blank and admin stuff there. But it takes almost a full day to do a good job of putting that all together. So you're looking at maybe one person's time for a whole day, and that's assuming we can get a whole day on it. So I know in a lot of other commodities, the typical ticket price on a nutrient management plan like that would be anywhere from $1,200 to $2,500 for an individual year. So there was an exceptional value provided through that project. We are looking at doing it as a service. We'll never get to the point where we will be charging growers $2,000 for a plan, but it might just be a much smaller plan in the future.
Hi Jay, it's Tim Wynot. Sorry if I missed it, but I didn't see you mentioned nitrogen within the plan. Where does that fall? Is that always low or?
So the thing with nitrogen, we don't test our soils for that okay, so nitrogen is highly, highly mobile in soils. So to actually get a good idea of how much nitrogen is present, you'd have to be testing your soils pretty well every day. So for us to come out in the fall, take a sample and get the nitrogen value on that, by the time spring rolls around, you're doing your fertilizer, it's not going to be the same number. So what we do in that case is we just make an assumption as to the optimal condition for nitrogen that we need in a lot, and also an assumption as to how much is used per year. So I think the optimal condition we went with for 2021, based on the data we found this year, was 130 kilograms per hectare. But that wasn't based on our soil samples because we don't test for nitrogen in our soil sample with the methodology that we use. Does that make sense?
Yes, yeah, good, thank you.
If not, you are welcome to take off. Thanks for joining us again. We'll see you in June.